Good morning, everyone, and thank you for being here today. I'm delighted to welcome you to this presentation on the role of 70% isopropylalcohol in contamination control strategy. Today, we'll explore how this essential sanitizer contributes to maintaining cleanliness and safety in our processes. We'll cover its applications, benefits, and the importance of proper use to ensure optimal contamination control. So, let's get started and delve into this important topic together. Let's start with the introduction. Today, I want to talk about a key disinfectant used extensively in the pharmaceutical industry. That is 70% isopropyl alcohol, or IPA for short. It's widely recognized as an effective disinfectant in various pharmaceutical settings. The chemical name, of course, is isopropyl alcohol. You'll find it used in cleanrooms across different grades, from grade A to grade D, ensuring a high level of cleanliness. It's also employed to disinfect equipment and surfaces, helping maintain sterile environments. And of course, it's essential in aseptic operations, where maintaining sterility is critical. In the pharma industry, IPA is considered the standard disinfectant, thanks to its proven efficacy and versatility. So, as we move through this presentation, keep in mind how fundamental IPA is to maintaining safety and cleanliness in pharmaceutical processes. Let's talk about why 70% isopropyl alcohol is more effective than absolute alcohol when it comes to killing microbes. The key here is its mechanism of action. It denatures proteins, which essentially means it causes proteins within the microbes to lose their structure and function. This process leads to disruption of the cell membrane, breaking down the barrier that keeps the cell intact. As a result, there's leakage of the cytoplasm, and this ultimately causes cell death. What makes 70% IPA particularly effective is its ability to penetrate the cell wall and coagulate proteins efficiently. The presence of water plays a crucial role here. It enhances penetration, making the alcohol more effective at reaching inside the microbes. Water also helps improve protein denaturation, and it extends the contact time, giving the alcohol more opportunity to do its job. This is why the optimal concentration is around 60 to 80% alcohol. At 70%, we get the perfect balance, enough water to aid penetration and denaturation, but still enough alcohol to effectively kill the microbes. So, the combination of 70% IPA with 30% water is not just a random choice. It's a scientifically optimized formulation to maximize antimicrobial efficacy. Let's take a closer look at the role of disinfectants in pharma manufacturing. They are essential for maintaining a sterile environment, and their application covers several key areas. For example, surface disinfection is performed on equipment, walls, and floors to eliminate potential contaminants. Laminar airflow, or LAF, cleaning ensures that the clean environment remains uncontaminated by dust or microbes. Glove disinfection is also critical, especially when handling sterile products, to prevent cross-contamination. Material transfer sanitization helps keep everything moving smoothly without introducing microbes, and wiping vials and ampules is a routine step to ensure each container remains sterile before use. These disinfectants are used routinely in sterile and production areas because maintaining aseptic conditions is fundamental to quality and safety. Now, let's talk about their spectrum of activity. Effective disinfectants target a wide range of microorganisms, including gram-positive and gram-negative bacteria, fungi, and enveloped viruses. This broad activity is crucial for comprehensive sterilization processes. However, it's important to recognize their limitations. Disinfectants are not effective against bacterial spores, such as Bacillus species. Spores are notably resistant, which means that we need to use sporicidal disinfectants to effectively eradicate these resilient forms. This requirement is actually a GMP, Good Manufacturing Practice regulation, that necessitates rotating sporicidal disinfectants to prevent resistance and ensure ongoing efficacy. So, understanding both the capabilities and limitations of these disinfectants helps us better manage our cleaning protocols and uphold the highest standards of sterility in pharma manufacturing. On this slide, we're focusing on the expectations outlined in EU GMP Annex 1. One key point is the use of sterile 70% IPA in grade A and B areas. This is essential for maintaining a sterile environment. We also need to ensure proper requirements are met, such as sterile filtration using a 0.22 micron filter, and maintaining controlled preparation processes to prevent contamination. Monitoring of contamination is critical to quickly identify any issues before they impact the product. All of these measures are critical for ensuring aseptic processing compliance. They form the backbone of maintaining a sterile environment and safeguarding product integrity. Moving on to the regulatory framework, there are several key guidelines to keep in mind. The EU GMP Annex 1, last updated in 2022, sets specific standards we must follow. We also refer to FDA 21 CFR Part 211, WHO GMP guidelines outlined in TRS 961, and USP 1072 for disinfectants. These frameworks require us to use validated disinfectants, establish well-defined procedures, and implement rotation strategies. The rotation strategy is particularly important to prevent disinfectant resistance and ensure continued effectiveness. Overall, these expectations and guidelines work together to create a robust aseptic environment and ensure our processes are compliant with global standards. Today, I'll be talking about the preparation of 70% IPA, which is a crucial step in our sterilization process. First, it's important to understand that IPA, or isopropyl alcohol, at this concentration is highly effective for disinfecting surfaces and instruments. To prepare this, we typically start with pure isopropyl alcohol and then dilute it with sterile distilled water to reach the 70% concentration. This specific ratio is key because it optimizes the alcohol's ability to penetrate cell membranes and denature proteins, ensuring effective microbial kill. Getting the mixture right is essential. Too concentrated, and it might evaporate too quickly, reducing contact time. Too dilute, and it might not be effective enough. We usually use precise measuring tools to ensure accuracy. Once prepared, it's important to store the solution in a clean, sealed container, away from light and heat, to maintain its efficacy over time. This preparation process ties directly into our overall theme of maintaining high standards of hygiene and safety in our practices. Properly prepared 70% IPA ensures reliable disinfection, protecting both staff and patients, and upholding the integrity of our protocols. When it comes to contact time and application, it's important to remember that the surface needs to stay wet for the disinfectant to be effective. Typically, this contact time ranges from about 30 seconds up to 2 minutes, depending on the situation. Rapid evaporation of the alcohol means we often need to apply it more than once to keep the surface wet long enough. The overall effectiveness really depends on both how long we leave it there and the concentration of the disinfectant. Now, let's talk about how we measure that effectiveness through log reduction calculations. Suppose we start with an initial microbial load of 100,000 CFUs. When using an IPA, which generally gives around a 3 log reduction, that means we're reducing the microbial count by 1,000 times. So, starting from 100,000 after disinfection, we're left with about 100 CFUs. This results in a 99.9% reduction in microbes, which is significant, but it's important to note that it doesn't mean the surface is sterile. It's a substantial reduction, but not complete elimination. This highlights the importance of proper application timing and concentration to maximize disinfection effectiveness in real-world settings. Now, let's talk about GMP practices to ensure our sterile processes are effective and compliant. First, we use sterile filtered isopropyl alcohol, specifically 0.22 micrometers, to maintain sterility. It's important to label each container clearly with the preparation date and the expiry date, which is typically no more than 1 month to ensure product integrity. When applying the alcohol, we use a spray and wipe technique, which helps evenly distribute the disinfectant and remove contaminants efficiently. Gloves are a critical part of this process, and they should be sanitized frequently, roughly every 10 to 15 minutes, to prevent cross-contamination. Now, it's worth emphasizing that shelf life and proper labeling are not just good practice, but are actually regulatory requirements. Moving on to validation requirements, as per GMP, we need to conduct surface challenge studies, environmental isolate testing, and contact time validation. These steps are essential to demonstrate that our cleaning procedures are effective and consistent. The key outcomes we want to demonstrate are a consistent reduction in microbial load and reproducibility of results over time. This isn't just about following rules. Poor validation can significantly increase the risk of contamination, which could compromise product quality and patient safety. So, thorough validation isn't optional. It's fundamental to maintaining a safe and compliant operation. When we consider risk and safety, it's crucial to remember that fire hazards are a significant concern with many disinfectants. Always ensure you're using these agents in well-ventilated areas to prevent the buildup of fumes. Personal protective equipment, or PPE, is mandatory to protect yourself from potential exposures. Additionally, proper storage is essential. Keep these substances in designated flammable cabinets to minimize risk. Controlling VOC emissions is also important to reduce environmental and health impacts. From a regulatory standpoint, safety compliance is mandatory under Good Manufacturing Practices, or GMP, to ensure safe handling and storage. Now let's look at the advantages of these disinfectants. They offer rapid antimicrobial action, which means they work quickly to eliminate microbes. They leave no residues, so there's no need for extensive rinsing, and they are generally easy to find and readily available. Plus, they're cost-effective, making them a practical choice in many settings. However, we also need to be aware of their limitations. For instance, they are flammable, which requires careful handling and storage. They lack sporicidal activity, so they may not be effective against bacterial spores. Also, because they evaporate quickly, the contact time with microbes can be reduced, potentially impacting their efficacy. Overall, understanding these safety considerations and the pros and cons helps us make informed decisions about how and when to use these disinfectants effectively and safely. All right, let's look at some practical examples to reinforce these concepts. When it comes to the grade of filling area, one key point is that gloves should be disinfected regularly, ideally every 15 to 30 minutes. This helps prevent contamination during the filling process. Additionally, before starting any operations, the LAF surfaces should be wiped down thoroughly. Keeping the environment clean and sanitized is crucial for maintaining the integrity of our sterile conditions. Moving on to material transfer, we use IPA spray in the airlocks. This step is essential because it helps sterilize the materials as they enter or leave the controlled environment, reducing the risk of introducing contaminants. And finally, all these procedures are based on standard operating procedures, or SOPs. Following these SOPs ensures consistency and safety in our processes, making sure we're always aligned with best practices. So, in summary, consistent disinfection, proper material transfer, and strict adherence to SOPs are vital to maintaining the high standards we've set for this process. Let's wrap up with some key takeaways. First, 70% IPA remains a critical disinfectant in pharmaceutical manufacturing. It's widely used because it effectively reduces microbial contamination when applied correctly. Importantly, this aligns fully with industry standards and regulations, including GMP, EU Annex 1, FDA, and WHO guidelines, ensuring we meet all necessary compliance requirements. However, it's essential to understand that IPA is not a sterilant. While it helps control contamination, it doesn't achieve sterilization on its own. That means we need to validate its use carefully and rotate it as part of a comprehensive cleaning and disinfection strategy. Proper validation and rotation are crucial to maintaining its effectiveness and preventing resistance. So, in summary, IPA is a vital tool in our contamination control arsenal, but it must be used thoughtfully, validated properly, and rotated regularly to ensure optimal results. For further support, please don't hesitate to reach out. We're here to help you with any questions or additional information you might need. Feel free to contact us through the provided channels. And with that, I want to sincerely thank you all for your time and attention today. I appreciate your engagement and look forward to working with you moving forward. Thank you once again.